Hi everyone, I hope my voice is fine because I usually talk really softly. Anyway, today I'm going to talk about GraphQL in Python and just a little bit about Django, because I guess this is not, I used to do this talk at DjangoCon, so it was more about how to use it with Django, but this time it's going to be more about GraphQL and Python. So yeah, my name is Patrick. I work as a backend engineer at the startup called Verve in London. And I'm also a chairperson of Python Italy. We organize conferences like this in Florence every year. And you can find me as Patrick91 online. So this talk, as I said, is about GraphQL. But before explaining what it is and why it's being created, let's go back and see how the web was like about 10 years, 20 years ago. So it was more or less like a collection of documents where you would interact with them using links and maybe forums. And those pages were all just HTML and CSS, so just like static pages that you really didn't have much control. It was just like a collection of documents. And you would have usually like a single server that was serving them. But over time, the web has changed. We got Web 2.0 and the evolution of that. So now we can have like multiple servers and different kind of clients. So we can have smartwatches, phones, tablets, and even fridges, for example. And you might have like a single server that acts as an API gateway, so you can communicate between those clients and those servers. So one of the ways you did communication with those clients and servers is to use APIs, and more specifically REST APIs. If you don't know, REST is basically is a design pattern that says that your resources on the server are basically linked to URLs. You would have one URL endpoint to each resources, and then you use HTTP verbs for doing operation on those resources, like get to get data, delete to delete, and put to update. Yes, I really like the design of REST, but it's good, but there are some shortcomings. For example, one of the issues is that you might have to do too many API calls, or something that's called underfetching. Let's say that we have this API where we can get a user by ID, and this we return something like this. So it's a JSON where you have the name, list of friends, and the avatar. So you can see each friend and the avatar, they are links to other resources. And this follows the, I think it's called hypermedia link patterns, which is quite good. But the problem with this, that if you need to get all the users, if you, for example, you have a page where you're showing the users, friends, you have to do an API call for all of them. And usually you will solve this by creating a new endpoint that will return like a different shaped JSON. So for example, you will get the friends with the names. The problem with that is that if you need to change the JSON response, you might need to create another endpoint. And especially if you have like big application, you might end up with loads of endpoints. And like maintaining this is really, really hard, especially, as I said, if you have different clients, if you have different pages, if you have different resources. There are some way to improve this, but still it's not great. For example, Coursera that's now migrating to GraphQL. At some point, they have over 1,000 different REST endpoints, and they had to maintain them, they had to document them, and so on. So the other issue is too much data or overfetching. So for example, you have a mobile application where you only need some fields. And let's say that you had the API before, and instead of creating different endpoints, you created just one where it's going to return all the data. So you get something like this. But basically, this is a waste of the user bandwidth and CPU, because basically you're returning data that's not used on the clients. So it would be a bit too much. So yeah, while REST and hypermedia links are great, they are not always the best choices for building a website or especially applications. So the other issues, and that's deep into my heart, is documentation. We used to have Swagger, which is basically an interface where you can basically document all your endpoints and all your actions. So for example, we have ping, raise, ring, and so on. But this is while this is fine, if you don't have a tool that helps you building this, it's really cumbersome because you need to update documentation alongside with your REST API, and it always happens that some endpoints are not documented, some of them are old, and so on. So can we do better? We could extend REST, for example, adding query parameters to change the response, using headers to basically intercept the client, say, oh, if this client is a mobile application, I'm going to return the smaller images. But everyone is going to do it differently. There is not a standard way. In fact, REST is not a standard, it's just a design pattern. And if you check all the APIs that are built with REST, all of them, they are slightly different. So it's not super nice. So this is where GraphQL comes in action, I guess. It's been created by Facebook in 2012, and it's been open sourced in 2015. So it's an open source specification. And what's important is that GraphQL, it's a query language. It's called as a query language for APIs, but it doesn't really mean that you have to work with graphs. It's just a name. And basically allows you to define the response of the API. I'm going to show you an example in a moment. Also, it's important that GraphQL is a specification, so it's a standard, and it's open source. So if you want to, for example, extend GraphQL, you can submit like a proposal, and they're going to discuss, and maybe they can improve it. And it's quite interesting. And the other difference is since it's a specification and it's not really tied to HTTP, so you can use GraphQL with any kind of protocol that you want. The common usage is with HTTP, but you can also use it with WebSockets and I don't know, other protocols that you might need to use. Usually with HTTP, you have one single endpoint, which is usually /GraphQL, and you do a post request to this endpoint. And what you send to this endpoint is basically a GraphQL document that looks like this. So it's similar to a JSON, but it doesn't have the values, and there are some slightly differences. For example, you can pass arguments to the fields, and so on. And basically, when I run this query, basically what I'm saying is I want the user with ID 1, and I want to get the name, the friend's name, and the avatar. And the response would be something like this. So basically, just what we asked for. And the other nice thing, if you were here yesterday, there was a nice talk about typings. GraphQL is typed, so every GraphQL API has a schema, and all the fields in this schema have types. So for example, like a simple schema for the API that we had before is this one. So something to note, like you have all the types. There is one type that you cannot really see, but it's called query. It's basically the root type for when you're trying to getting data from a GraphQL API. So you always need to have a query. Then you need to specify fields. So for example, we have a user fields, which has an argument ID of type ID, and then it returns a user. So this is basically the schema that we had before. Also, we had like a type user with name, friends, avatar, and then we have a type friend. Yeah.
Just the slide before. Why there is no exclamation mark after user?
Here, yes. That's because imagine if you're passing an ID that doesn't exist. The user might not exist. So it means when you use exclamation mark, it means that it's going to return something. It's like required. In this case, it might not return something. And I'm going to show you actually something quite cool about this later. So you have different kind of types. You have scalars, so there are like simple types, integer, float, strings, and any user defines scalars. For example, in a Python library, there is a datetime scalar. And then you have object type, which is basically like a dict. So it's a collection of fields linked to other types, which can be either scalar types or other object types. And you also have type modifiers, which are like lists. So basically you said this field is going to return a list of a type. And then non-nulls, which is the exclamation mark, where you can say this field is non-null. Why is this important? Like types are really useful for like a number of reasons. I think something that I quite really like of this is having setting checking. So for example, when you have a client, when you have control on the client, you can basically do, oh, I have this GraphQL client, I have this GraphQL query, I want to check on the API if this is actually valid. And you can you can have this in your continuous integration and check every time if the queries that you're doing are valid or not, which is really helpful. And also you have documentation and introspection, because since you have types, you don't really have to document the API. I'm going to show an example of the introspection right now, because it's really helpful. So you can use IDEs like this one, where you can basically try GraphQL, but also it's going to help you with auto-completion and all the stuff. You also have a schema button here where you can see all the schema, and also you can, for example, if you want to add some additional documentation, you can also add description to the field, so you're going to get that built in. So yeah, a difference with I guess REST API is that you don't really use HTTP anymore. You don't use HTTP verbs. You always do a post request. So you have operation for like doing different things. So if you want to get data, you do a query. Sorry, that's a bit small, but I'm going to read it. So you have a query to fetch data from the server. It's like a get. Then you have mutations, which are basically anything with side effects. So for example, you can send an email, you can create a user, add the comment, and so on. And then you have subscription, which are basically a way to subscribe to events. For example, you can subscribe to when a user adds a comment to a blog post and so on. And this is all built into GraphQL, and they all work the same way. So as I showed you already how to do a query. This is like a shortcut version, since it's like a popular operation. So there's a shortcut for it. But the actual query would look like this. So you have to pass the query name, the operation name here. Then there is a query name. This is not really important. It's only used for debugging or for logging, for example. Then you can pass the parameters here for your query, and then you can use the parameters here with all the fields that you're requiring. The way you pass the parameters here, it's quite useful, because you can have this query, and then you can, when you send the query to the API server, you can send the query and the variables as a separate entities, so the query is always the same. It doesn't change. You don't have to change, like put the actual variables in there. You can send them as a separate field on the API. Then for mutation, it's basically the same. Changes the operation name, and then you have variables and so on. Same thing for subscription. So they all work the same. It's only changed this bit here. Let me drink a bit. So, GraphQL in Python. Until I think a month ago, there was only one library. There are two libraries. One is really new. It's called Ariadne. It's been created by Mirume Labs. And the reason why it was created, I think it was because the other library it's good, but it's not. It's a bit like, it's more like an abstraction on top of GraphQL. While Ariadne is close to GraphQL, where you work actually with the types, and I'm going to show this in a moment. Only works with Python 3.5. I guess that's fine now. Then, yeah, the other one, the most popular one, is called Graphene. Actually, I'm a contributor of this library. Supports Python 2 and Python 3, but Python 2 is going to be removed at some point. And it's actually a nice abstraction on top of GraphQL. So it's like a Django ORM, if you know that. And yeah, it supports Django and more frameworks like Flask, for example, and SQL Alchemy, if you use that. So let's start with Ariadne. The first thing that we need for creating an API in GraphQL is it's a schema. So as I said, with Ariadne, you work with the schema directly. So for example, we can type by hand all the schema in GraphQL. And then as soon as we have this, we need a way, yeah, just want to iterate again. You have fields for each type, so you basically, GraphQL works with fields, and then you need to have at least one query. And then you need to attach the data to those fields. The way you do this is using resolvers, which are basically functions that you can attach to those fields. So Ariadne by default uses a get-out and get if you're using a dict. But basically, you can attach a function like this. So let's say that we want to do a resolver for a user. So you create a function. The first argument is the parent. In this case, it's the query, so it's not. We don't really need it. There's info that's just context about the request, and then you have an ID. In this case, I'm just ignoring the ID because otherwise it might be more But yeah, basically I'm just returning a JSON here, like this. And then I need to attach those resolvers to a type. In Ariadne, the way you do it, you create a dict called resolvers where you can pass the type, and then you can specify the fields and the resolver. And you can do this for each type. As I said, if you don't specify a resolver for a field, for example, in the user we had the friends, it's basically going to do a get on the data that's going to be returned. So it's doing some magic for you, which is quite helpful. And then you need to create a simple server like this. So you pass the schema and the resolvers. And this is similar if you're going to check, because GraphQL is more popular in the Node.js community, if you're going to check how the servers are done on Node, it's similar to this. So that's done. I'm going to show you quickly like a demo, because I think if it doesn't always work. Well, this is really small. Let's see if I can. Yeah. Okay, this is an API that I've built like yesterday using Ariadne, and basically you can see, as I was saying, you get the schema for free, so you can basically have a documentation of the API like this. So, for example, we know that we have these queries, this mutation, and if we had subscription, we could see all of those. And when you click on one of the query, I can see the type, I can see the arguments, and if there was some like documentation, I could also read that here, which is quite helpful. And it's really good because, for example, if I want to do this query, I only need the name, I can call it, and it's going to return just the name. But if I want to get the friends list and the name of the friends, I can do it. And I can change the query, and that still works. It's basically returning what I'm asking for. It's not returning anything more. And about the required fields, for example, in this case, all the fields are required. But actually, I've added another one that's called these field errors, which is not required. So you can see there is no exclamation mark. This is basically a field I added for an example to show how errors works in GraphQL. So I can request that one, and let's do these field errors. So you can see when there is an error in GraphQL, you get a errors response, but you still get the rest of the request of the response, because basically GraphQL it's quite tolerating with errors. So for example, if you have a big query and there is something that fails, you can still get the rest of the data. Which is quite helpful if you're building an API that some data is not really required. Let's see. Cool. Cool. The next library is Graphene. As I said, this is an abstraction on top of GraphQL. So the schema is defined in Python. So basically, you create classes for your schema. So let's say that we have this schema with friend, user, and query. So let's define the friend type. So basically, create a class that extends graphene.object type, and then we define the fields like this. So you see there is a name, which is a string, and it's required. Oops. And for the resolver, they basically live together. They live together with the types, usually. They can also be external functions, but they usually are functions on the class. So in this case, for example, I'm creating the user type where there's a name, list of friends, an avatar, and then I'm creating a resolver that's basically returning just a list of friends. And in this case, with Graphene, you have to return the actual type, because otherwise Graphene is not going to do get on the dictionary if you're returning a dictionary. Then the query looks like this. So we have a user, which is a field of user type, and you can pass an argument that's an ID. And then you have resolver, where you can get the parent, the info, and the ID. And basically, in this case, it's just returning a user type with the name and the avatar. And then you can create the schema like this. And that's it. Basically, you created the API just like 3 classes. And it's really powerful, especially because it has Django support and support for SQL Alchemy with that, and Flask. So especially with Django, it means that you have a built-in view And basically, you don't have to build your own view for receiving data. It's already built in. You also have an ID, like the one I showed you before. You can create types of Django models. So if you have a model, you can create a GraphQL type based on that. And also works with forms and Django REST framework serializer. So if you have a REST framework API, you can use some of the serializer with Graphene. And also you can use Django filters, which is a third-party library to do filtering on your queries. So now I'm gonna go about a bit into like some of the questions I always see on GitHub or Stack Overflow. So one is like, how can I do authentication with GraphQL? Well, there are three ways of doing it, especially because we are using HTTP, so we can still rely on the building blocks of the web. So we can use sessions, we can use HTTP headers, and we can also use field arguments. So session, you basically rely on the browser sending cookies to the server and the server receiving them. And so you can check if the user is logged in using the session, which is pretty straightforward, works really well with Django, and it's easy to implement. So the other one is to using headers, which is something you usually do with REST APIs. So basically you send an header with a token, and usually it's like JWT, or it can also be basic code, and you use that token to check if the user is logged in or not. And this works really well if you have an API that's used by third parties, or you have a mobile application, because you can really use token cookies. And the last way of doing it, which is quite interesting as well, is using field parameters. So if you have just a few fields that require the user to be authenticated, it's probably easier to just use a parameter on your field, because you can pass arguments to any of them. And for example, we have a bank statement here that receives a token, and then you can basically use this token to check if the user is logged in or not. I usually go with session because it's easier to implement, and it's mainly, the APIs that I've built, they don't have third-party clients, but if I were to use third-party clients, I would use headers. The last one is about security. So we are giving a lot of control to the user with GraphQL, because we're basically allowing them to query data on our server. So they know what data is on the server. They can do different kind of stuff with the queries. So it's really easy to create malicious queries. So for example, something like this, where you're fetching a thread, the first 100,000 messages, and each message has got a thread where you can get the messages, because basically it's like a kind of a tree of messages. And imagine if this would be repeated like 10,000 times. This would be a long query on your server, which basically means that your server is not going to return it, it's going to crash at some point, especially if someone is like trying to DOS you. So there are 4 solutions on this. So the first one is timeouts. This is, I think it's implemented by Facebook. Basically, they check how long a query is taking. If it's taking more than, let's say, 1 second, they basically kill it, because for them, 1 second is already too much for a user. Basically, they want the response to be as fast as possible. So if it's something that's taking more than 1 second, they basically return an error to the user, and they can try again, maybe. Yeah, it prevents huge queries to DOS your server, and prevents long waiting time for users. The other one is to have some limits on the nested fields, which basically, since you're basically sending a document, you can parse the document and check how many levels of nesting they're asking for. So for example, if they're asking for, I don't know, more than three levels deep, you can say, oh, this query is not allowed, and return an error to the user, because it's something that probably should not happen. Then the other one, this one is implemented by GitHub. It's a bit more complex, but it works well if you need to, for example, limit the API for specific third party. For example, if you have an API where you give access to external users, external clients, and you want to say, oh, they can only do, I don't know, 10 queries per minute, something like that, you can use query cost. So basically, the idea is to give each field a cost, and then you can calculate the cost of the query, summing the fields times the number of times you're requesting that field. I'm going to show an example because it's really easier to understand like this. So in this case, we're doing a query where we're getting the first 50 repository, and then for each repository, we're getting the first 10 issues. And to calculate the cost is like this. So it's 50 repository plus 50, which is the cost. It's the number of repositories times 10, which is the number of the issues that we're getting per each repository. So the cost would be 5 under 50. So you can decide if this query is too much for you and so on. You can also store how many nodes someone has been asked for, like in the last 5 minutes, so you can also limit that. That might be helpful. GitHub is doing this because they basically want to rate limit their API, and like doing rate limiting like REST is not possible because you only have one endpoint. And then the last one, which is really interesting, but it's not easy to implement, is using static queries, which basically instead of sending a document to the API, you send just an ID, and basically your GraphQL document will live on your server, which basically means that when you receive this ID, you're going to fetch from a database or somewhere else the document, and you do use that document to do the query on your server. And this works really well for security because basically you only have like a limited subset of queries that you can run. It still allows you to use all the advantages of GraphQL because you can still do custom queries. But it's a bit cumbersome to deploy because basically you have to store the queries that you're doing on the front end or on your clients in the database or somewhere. And also, if you have third parties, you need a way for them to declare queries. So, for example, interface where you can put the query they want to do, and then they can basically save it and then can use it. If you ever use Twitter, I think Twitter is doing something like this, where you have to declare the API calls that you want to do before actually using them. And it might be good for caching, because instead of doing a post request at this point, you can do a get, and then you can cache by using the ID parameter, which brings me to caching. Caching is a bit hard with GraphQL, because you're using post request, you cannot use something like a cache like Varnish or something else. So there are like 3 different ways that you can do caching on GraphQL. One is using client caching, and this I think it's really important, and it's not that hard to do, especially if you use the libraries I'm going to show you in a moment. Basically, you cache as much as possible on the client. So if you have a mobile application, all the data that you need, you're going to save it. And if you're requesting the same data, you basically go back to the cache instead of going online, and you might need to invalidate those data at some point, but in some cases, it's really easy. Then you have network caching. This works if you have GraphQL APIs, which are basically wrappers of REST APIs. So for example, at Verve, we basically have REST API that's kind of internal, and then we have on top of the REST API, we have a GraphQL layer, so our clients, they do API calls to GraphQL, and then we do the REST calls to our backends, and basically we can cache those on using something like, I don't know, Varnish and something like that. We basically can rely on like standard REST cache if you're using that. And the other one is application caching, and this might be useful if you have fields that are quite expensive to calculate. For example, you have a query that's basically going to an external service and it's taking a few seconds. You can cache that on the application level. So the first time I take a second, but then it's cached on the application. And I still have some time. So there are some additional things I can talk about. And so, yeah, arguments and inputs. I showed you quickly this. It's just basically each field can have arguments, and this is really powerful. For example, imagine if we had the avatar from before, we can also pass the sides, and so this basically allows to make super dynamic query. But if you want to pass like something complex in here, like for example, this is just a string, it's a scalar. If you want to pass something complex, for example, in a create user, you have to use something that's called input types, which are basically an additional kind of types. It's like an input type, where basically it's like a type, basically it's only used for inputs. Then you can have enums, which are basically just like Python enums. You can also have interfaces. This is useful if you have something that's basically like extends some other types. For example, you can use a interface like this. Oh, sorry. Sorry, I forgot to. This is actually not an interface, but this is a union type, and but it works similar as the interfaces. Basically, when you use something that's generic, so like a union type, an interface, you have to specify the type. So basically, you can have a query that returns different kind of types, and this is quite helpful if you have something that's quite dynamic. So imagine if you have a search for an e-commerce where you're returning a product, but you're also returning the FAQ pages and something else. That's really powerful because on the clients you can basically use those type information to display something different. And yeah, errors are important. I showed this before. It's basically you can have, so this is a field that doesn't exist. When you try to do a query that's not valid, GraphQL is gonna kind of explode, so it's basically not gonna do the query for you. But if you have just a single field, like in this case, it's still gonna return you data. Actually, I'm gonna show you this because it's easier to go slow on that one. Okay, so you can see this. So this is a query that is actually asking for a field that doesn't exist. So the ID is already helping me say, oh, I cannot query this field on this type. But if I try to do it, GraphQL is gonna complain, oh, I cannot query this field. And this is quite helpful, especially if you like debugging and try to do some crazy stuff. And you also have field errors, as I showed you before. So basically, you can ask a fields that might return an error, and you basically get the errors here. They're not super helpful, but you still have the data back. So the field is going to return null, but you still can get the name. So this might be helpful, for example, if you're fetching a blog post where the comments, for some reason, they fail, but you still have the blog post. Then, yeah, the other thing it's interesting is like mutations. So basically, they're like functions. So they work the same as query. So basically, this mutation right now only returns one field, which is a Boolean. So imagine if I had more fields, I can actually request them. I can say, oh, I want to create a blog post. I want to send an email. I want to get all these fields back. But if I don't care about the fields, I don't really have to fetch them. So in this case, it's basically returning just a Boolean. Let me show you this one as well. Okay. So I built this small API for DjangoCon, which is basically a GraphQL API that returns a list of pools, and it's going to return a list of pools with the question and the ID. It's also returning the choice set. So if we want to get the choice at the number of votes, I can quickly do it. So basically, for example, this is like a test pool that I created. The first choice has got 6 votes and so on. If I want to vote, I can do it. Let me just remove this. So I voted by not getting anything back because I didn't ask for it. If I want to, for example, if I want to get the pool back, in this case, and the question and the choices, I can get it like this. So you can see every time I vote, this is updating here. And this is built using Django. And there is also, let's see if I can find it here. Oh God. So I want to show you how subscription work. They basically work the same as query. So you can say, I want to do a subscription. I want to subscribe to Unpoll updated, and then I want to get the question, the choice set, and for each choice I want to get the text and the votes. So if I run this query, the way I built it is basically the first time it's going to return the set of polls that we have. And if I do, let's see. So if I update, if I do a mutation here, this is going to update at the same time. So basically, this is using a WebSocket under the hood, and it's doing it's updating the data in real time, which is really cool. And you don't really have to do anything for it. It just kind of works. With Django, you have to use Django channels, but that seems to be quite fine. And let's see. There's more stuff with GraphQL. You have directives, aliasing, and it's like a big specification, but it's really powerful. Just gonna go quickly on frontend because I'm sure someone is gonna ask me. There are frontend really benefits from GraphQL, I think, more than the backend because the tooling is really great. There are two libraries. One is Relay, which is made by Facebook and only works with React. I haven't used it personally, so I'm not sure what are the benefits. But the other one is called Apollo. I think it's one of the best libraries I ever used. It supports many frameworks, so you can use React, Vue.js, Angular, and I think even without frameworks. It's got a big community, lots of tooling. And if you want to talk about this, I can show you some example later because it's really cool, but I don't have time to show it. And if you want to work with Python, GraphQL, and Django, we are hiring. So if you want to talk, we can speak with me. And yeah, if you have any question, just ask. Thank you.